So how this vector space representation of the word is used in the semantics. So here we have to represent our DSM like this. So here we have to represent the vector like this. First, let us consider this V. V is represent like this. Okay. Why? Because it is represent the 5 as a x value and the 6 is a y value. Then the vector of this, yes, this is your x value, this is your y value. Okay, so this is your vector space representation of the node A and B. The same we are used here, drive and the it. So let us consider there are the two, drive and the it. Now I want to find out the vector representation of the one of the sentence, and in that sentence there are the words cat, dog and the car. Okay, so now this cat is more near to the it and the dog is also very near to the it as compared to the drive. While drive word is more related to the car, so you can see that this vector is near to drive, and this vector cat and dialogue are near to it, because this it is related to the more related to the cat and the dog, while the drive is more related to the car. Okay, so this is a representation of the vector representation of the word. So you can also represent your word as a vector. So from this you can conclude that the cat and the dog are quite similar as compared to the cat and the car or dog and the car. Okay, so these two are more related to each other, cat and the dog. Cat and the dog are more similar, or they are more related to each other as compared to the cat and the car and the dog and the car. There is no relation between the cat and the dog. There is no relation between the dog and the car. But you can say that the cat and the dog are more related. Okay. Now, how you can say that they are more related? So let us consider they are the pet. First one, you can say that these are the animal and they are the pet animal. They have the 4 legs. Okay. They have the tail and all these things. Right. So you can say that the cat and the dog are more similar as compared to the cat and the car and the dog and the car. Now, what is the data set we have to use? So to represent this DSM, we have to use the one small data set. Let us consider this is my data set of paragraph 1, 2, 3, 4, 5, 6, 7, 8 sentences are there. Okay, and automobile is a wheeled motor vehicle used for transporting the passenger and all these things. Okay, so from this data set, so this is my data set. From this data set, it's kind of the target word, and I have to use the term vocabulary. Okay, so this target word and the term vocabulary. So target word, what are my target word? My target word are automobile, car, soccer and the football. Okay, so now I want to find out the correlation between these target words. So is the automobile and the car having some relationship? Is the automobile and soccer having some relationship? Is the car and the football having the relationship, or soccer and football having some relationship? So this is my target variable or target word, and my term vocabulary, my term vocabulary is, you can see that there is a win, transport, passenger, tournament, London, goal and the match. Okay, so these are my term vocabulary I have selected. Now, how to construct the word space? So for constructing the word space, informal algorithms for the constructing the word space are pick up the word from your interest in a target word. Okay, so you are randomly pick up this word. Okay, so you have to randomly pick up this word from your data set and treat it as a target word. Then define the context window. Define the context window. So what is the context window? The context window can be generally be defined in the term of document, paragraph or sentence. Okay, so there are the 3 types of context window, you can say that. So So you can say that this target word means automobile, car, okay, or football. What is this? These are my target word. Okay, football. So you can find out this word either in a document, either in that particular paragraph, or either in that particular sentence. So you have to find out the window. Window means from where to where, starting to end. So this is my window. So in that window, I have to find out this target word. So how many times the football word is occur? How many times this automobile word is occur? How many times this car word is occur in my window? So this is my window. Okay. So this window, either it can be said that it is one of the documents, either it is one of the paragraph, or either it is one of the single sentence. So in that particular sentence, how many times this football is occur? How many times this automobile is occur? How many times this car is occur? So this is called as a context window. Then count the number of the times the target and word co-occur with the context word. That is called as a co-occurrence matrix. In the next step, what we have to find out? In the next step, you have to count the number of the times of target word co-occur with the context word. Okay. So using in that particular context, how many times this football, this automobile, and this car is occur? So you have to find out it. And then you have to build the vector out of this co-occurrence count. Now, so this is the output of this distributional matrix, represent as a distributional matrix. Here, I am taking my target word. What is my target word? That is the automobile, car, soccer, and the football. Okay, that we already taken. Now, these are my words. Wheel, transport, passenger, tournament, London, goal, and the match. Okay, so in the distributional matrix is nothing but target word. This is my target word into context word, and this is my context word. Okay, so in my context word, how many times this word is occur? So automobile and wheel is occur one time. Automobile and transfer occur one time. Automobile and passenger occur one time. Automobile and tournament occur 0 time. Automobile and London occur 0 time. Automobile with a goal occur 0 time. Automobile with a match occur 0 time. As compared to football and wheel occur 0 time. Football and transport is occur 0 time. Football and passenger occur 1 time. Football and tournament is occur 1 time. Football and London is occur 2 times. In my particular window, I am telling you this is one of the window. In my particular window, how many times this sentence or this word are occur? So football and the goal is occur 2 times. What football and match is occur 1 time. Okay, so this is called as a distributional matrix. And how you can develop this distributional matrix? So this distributional matrix is developed by selecting the target variable and the target word and the context word. Okay, so this is a distributional matrix you have to develop. And once you develop the distributional matrix, you can take any 2 dimensions. For example, I am taking out of this goal and the transport. Okay, so goal and the transport. I am taking these 2, goal and the transport. Okay, now goal and transport, you can say that these are occur football. How many times football is occur? In this football occur 2 times. See, goal in a football is occur 2 times. And the soccer is occur 1 time. Soccer is occur 1 time. Okay, and then automobile 1 0 and car 2 0. So in this way you can develop the your graph also from this matrix, and finally this is your computational similarity. And from this matrix you can generate the computational similarity. So what is my computational similarity? The computational similarity say that the automobile and the car, it is a dot product. Okay, automobile and the car, okay, is equal to 4. So how it is? You can say that is a 4. So 1 into 1 1, 2 into 1 2, and 1 into 1 1, 0 into 0 0, 0 into 1 0, 0 into 0, 0, 0 into 0, 0. Okay, so you can say that this is 1 plus 2, this is 2 plus 1, this is 1. Okay, this is 0, this is 0 because 0 into 1 is 0 plus 0 and plus 0. And that's why it is a 1 plus 2 plus 1, that is nothing but the 4. So it is simple dot product. Okay, so automobile and the car having equal to 4, automobile and soccer, automobile and soccer. So you can make a this dot product. Okay, automobile and soccer, you are getting the 0. Automobile and football, you are getting 1. Car and soccer, you are getting 1. Car and football, you are getting the 2. And soccer and football is equal to 5. Okay, now you tell me that what this output is indicating. Yes, class. From this output, computational similarity, what you understand? Let me ask. Yes, Atharva Devlikar. Hello, Atharva. Rutuja. Abhishek Pool.
Yes, sir.
From this dot product, are you getting how I can find out this dot product?
Yes, sir.
Okay, so this is the output. Automobile and car equal to 4. Automobile and soccer is equal to 0. Automobile and football is equal to 1. And soccer and football is equal to 5 and all these things. So what this indicating? What this computational similarity indicating?
Sir, hello sir.
Yes, go ahead.
Here.
Yes, go ahead.
Sir, it shows that automobile and car is actually equal because it has highest number, and soccer and football too because they are similar. But car and football are not so similar. So is automobile and soccer. That's why the output is 0.
Very good. Exactly correct, Rutuja. Now I tell you. So this similarity, computational similarity matrix show that these two words, automobile and car, are more correlated to each other. So you can use automobile or car in your paragraph either, or this soccer and football is the highest, having the highest similarity. So either you can use the soccer or you can use the football, both having the same meaning. Okay, are you getting? So I'm again giving you the one example that when you find out some error in the word file. Okay, so you have to make the right click, and when you right click, so there is a word synonym. So synonyms, there is a not only one synonyms is there. Okay, always there you can find out there may be a 3 to 4 synonyms are given by the word. So what that synonyms means that the synonyms say that if you are clicking right click on the automobile, so either it can show that automobile means this, automobile like this, the automobile like this. Okay, so there are the few words, but their similarity can be, you can say that this is the number 1 similarity, this is number 2 similarity, this is the number 3 similarity, this is the number 4 similarity for this my word X. Okay, so when you click on the synonym. Okay, so it is also say that the computational similarity say that soccer and football are more similar word in this context. Also, automobile and car having the correlation to each other in this my context as compared to automobile and soccer. This is 0. Car and soccer, this is 1. Automobile and football, this is 1. And car and football, this is 2. Okay, so you cannot use this word for any further processing. You can use the soccer and football because they are correlated to each other, and automobile and car because their similarity is higher. Okay, so that's why you can either use these two words or you can use this word, and this is called as a computational similarity. I hope all of you now understand now what is the computational similarity.